Now let's see this problem. Straight lines y is equal to mx plus c1, y is equal to mx plus c2, where m belongs to positive real numbers r plus, meet the x-axis at a1 and a2 respectively and y-axis at b1 and b2 respectively. It is given that points a1, a2, b1 and b2 are concyclic. Then find the locus of intersection of lines a1, b2 and a2, b1. So let's represent the same what is given question in the diagrammatic form. So let's consider the two lines. Okay, let me take for my convenience. First I will draw the circle. And let me take the coordinate axis. Okay, and there are the lines y is equal to mx plus c1. Let me take this as a line y is equal to mx plus c1. So this is the line y is equal to mx plus c1, and another line y is equal to mx plus c2. So let me take this as y is equal to mx plus c2 line, cuts the x-axis at 2 points a1 and a2. So mark this as a1 and this is a2, and y-axis at points b1 and b2. This is b1 and this is b2. Okay, and since y is equal to mx plus c, it is an intercept form, slope intercept form. So we can say that y is equal to mx plus c1. So we get the point here 0 comma c1, where c1 is intercept, y intercept, and c2 is the y intercept for the second line. So we consider the point b2 is the point 0 comma c2. And also we can find the coordinates of a1 and a2 by taking y is equal to 0. So you will be getting that. So by substituting y is equal to 0, mx is equal to minus c1 or minus c1 upon m comma 0, and a2 will be getting minus c2 upon m comma 0. So okay, we got the coordinates here. A1 minus c1 upon m comma 0, a2 minus c2 upon m comma 0, and b1 we got it 0 comma 0 c1, and b2 is 0 comma c2. Okay, and now it is given that a1, a2, b1, b2 are concyclic. a1, a2 and b1, b2 are concyclic, means there is a circle passing through these points, and hence by the segment theorem, by one of the segment theorems, we can say that if O is the origin, we have OA1 into OA2 is equal to OB1 into OB2, right? What is OA1? OA1 is nothing but mod of minus C1 upon M into OA2 is nothing but mod of minus C2 upon M is equal to C1. OB1 is C1 and OB2 is C2. Okay, and this can also be written C1 C2 is equal to mod C1 C2 is equal to mod M times of C1 C2 M square times of C1 C2, which implies that M square is equal to 1 or M is equal to plus or minus 1, we can consider, right? So M is equal to plus or minus 1, and if M is equal to plus or minus 1, what are these 2 points we can consider, A1 and A2? And he was asking find the locus of intersection of two lines A1 B2 and A2 B1. So A1 B2, this is the line A1 B2, and this is your line A2 B1. So he was asking about the point of intersection of these two lines. So passing these two lines intersection, equation of line. So let me write equation of line A1 B2. So we had x upon or mx upon minus c1 plus y upon c2 is equal to 1, and equation of a line a2 b1. a2 b1 is we can consider mx upon minus c2 plus y upon c1 is equal to 1. Okay, and hence here we can write this equation also as minus mx c2 plus c1y is equal to minus c1 c2, and here we can write this equation minus m c2x plus c2y, sorry, this is c1x plus c2y is equal to minus c1 c2. And since equating these both equations, so we can add, since right hand side and both side equations are same, c1 c2 minus c1 c2 minus c1 c2 both are same, so we can equate the equations minus x c2 plus c1y is equal to minus m c1x plus c2y. Okay, and this equation we can also write bringing these terms here. Let me write here mc1 minus mc2 of x, and here c1y minus c2y is equal to 0. Or we can also write mc1 minus c2, m we can take common, c1 minus c2 of x plus, and here also if I take 1 common or y common, c1 minus c2 is equal to 0. Okay, and which implies here m is equal to 1, since we had m is equal to plus or minus 1, and also is given to you here m belongs to positive real numbers, so we consider m is equal to plus 1 since m is belongs to r plus. So if I take m is equal to 1, so we had c1 minus c2 of x plus y is equal to 0, and c1 and c2 is equal to 0, or x plus y is equal to 0, and c1 and c2 are two different constants, we cannot take c1 not equals to c2, so we consider the locus is nothing but x plus y is equal to 0. So x plus y is equal to 0 is the locus of intersection of two lines a1 b2 and a2 b1, hence the problem. Thank you.